Hey everyone, and welcome. We live in this incredible world where all our devices just connect. They talk to each other, they talk to the internet, and it all feels a bit like magic, right? But it's not magic at all. It's actually a system of really brilliant engineering. And today, we're going to pull back that curtain and show you exactly how it all works. So, let's get into it.
I mean, really stop and think about it for a second. You type in a website, hit enter, and milliseconds later, poof, it just appears. How in the world does your computer, the one sitting right there on your desk, reach out across the globe and just grab that information? What is actually happening behind the screen?
Well, the answer starts right here with something that, let's be honest, looks a little bit like organized chaos. This is what a large network looks like in the real world. It seems super complicated, I know, but the principles that make this whole thing work are surprisingly simple and elegant. And by the time we're done here, you're going to understand exactly what's going on. So let's start with the most basic question of all. Before we go any further, what even is a network? At its core, it's actually this simple. A network is just a group of devices that are linked together so they can share things. Think of any office. You've got computers, you've got a printer, maybe a server. They're all connected so that you can print a document from your desk or grab a file from a shared folder. That right there, that's the whole point of a network. Okay, so if a network is a bunch of connected devices, how do they, connect? Let's talk about the physical stuff, the different ways these devices are actually linked up. And it really just boils down to two main ways. You're either plugged in with a good old-fashioned cable, or you're connected through the air with a wireless signal. They both get the job done for sure, but they have very, very different strengths. And this really shows that classic trade-off. The physical Ethernet cable gives you that rock-solid, consistent speed and stability. It's perfect for something like a gaming PC or an office workstation, where every single millisecond matters. Wi-Fi, on the other hand, that gives you freedom. You can wander around your house with your tablet, and adding a new smart speaker is totally effortless. You're basically trading that raw, top-tier performance for pure convenience. And then, of course, there's Bluetooth. Now, it's also wireless, but it's not really for connecting you to the internet. Think of it more like a tiny personal area network. It's built for low-power, short-range stuff, which is why it's absolutely perfect for your wireless headphones, your keyboard, or your smartwatch. It's all about connecting your devices to you, not necessarily to the rest of the world. Okay, so we've got our devices connected, but with all of that data flying around everywhere, how does anything get to the right place? For that, we need some special hardware to act as the traffic cops of our network. Now this right here, this is a map of a pretty standard home network. You can see all the different pieces working together. Let's break down what the two most important players, the switch and the router, are actually doing. First up is the switch. I want you to imagine your local network is a single office building. The switch, it's like the super efficient mail sorter in the mailroom. When your computer wants to send a big file to the printer, the switch makes sure that data goes only to the printer, not to everybody else's computer. It keeps all the local traffic moving smoothly and directly. The router, on the other hand, has a much bigger job. So if the switch is handling the mail inside the building, the router is the main post office for the entire town. It's the device that takes all the data from your local network and sends it out onto the internet. And just as important, it's the gateway that receives all the data coming back in from the outside world. It connects your little network to all the other networks out there. So let's just nail down this crucial difference. A switch connects devices within your local network, your LAN, and it uses something called a MAC address, which is like a permanent, unique serial number for each device to direct traffic locally. A router connects entire networks together. It's what talks to the internet, and it uses the logical IP addresses we're about to talk about to send your data out to the globe. One manages the local scene, the other is your ambassador to the world. So we've covered the physical connections and the hardware that directs traffic. Now let's dive into the invisible magic, the secret language that allows all these devices to actually understand one another. And it all starts with the IP address. Every single device on a network, everything from your phone to your smart TV, has to have one. Think of it exactly like a unique mailing address for a house. Without it, the router would have no idea where to send that YouTube video you just clicked on. So where do these addresses come from? Thankfully, you don't have to type them in yourself. That's where a fantastic little service called DHCP comes in. When your phone connects to a Wi-Fi network, it basically shouts out, "Hey, I'm new here. I need an address." The router's built-in DHCP server hears this and replies, "No problem. You can have this one." It's this automatic, seamless handshake that happens in a split second every time you connect.
Now, we have an address, but let's be real. Numbers like 142.250.190.14 are not exactly easy to remember. We humans like names, like Google.com. So, to bridge that gap between names and numbers, the internet uses something that works, well, just like a giant global phone book.
And this phone book is called the Domain Name System, or DNS. So when you type google.com into your browser, the very first thing that happens is your computer asks a DNS server, hey, what's the number for google.com? The DNS server looks it up in its massive contact list and sends back the IP address. It's only then that your browser can actually connect to the website. DNS is the silent translator that makes the entire internet human-friendly. And there you have it. From the physical cables and the invisible signals to the hardware that acts like traffic cops to the secret language that makes it all run, you now have the core building blocks to understand what's really happening on your network.
So let's just recap the big stuff. First, networks are all about one thing: connecting devices to share stuff. Second, remember that how you connect, wired, Wi-Fi, or Bluetooth is always a choice between performance and convenience. Third, think of your hardware in layers. The switch manages traffic inside your home, and the router is your gateway to the outside world. And finally, don't forget the silent heroes: DHCP and DNS, the automatic systems that do all the heavy lifting to make it feel so easy.
So I'll leave you with this final thought. We've all had that moment, right? Your phone shows you've got full Wi-Fi bars, but nothing will load. The next time that happens to you, what's your first guess now? Has your device failed to get an IP address from DHCP? Or maybe the internet's phone book, DNS, isn't answering the call. You now have the tools to start thinking like a network detective. Thanks for watching.